Hi, my name is Nate, and I was a member of the mechanical team. I was in charge of making the base of our project as well as the final assembly for the actual project. Additionally, I also helped with fine-tuning our final design. Lastly, I also helped with the poster.
Hi, my name is Victor, and I was responsible for planning the laser cut for our rotating platform, as well as carrying out the cuts and assisting with assembly. I was also responsible for creating and managing a communication method, i.e. a Discord server.
I'm Jimmy, and I designed the rotating table, brackets, and clip assembly. I also helped with the general assembly of the first model and the final project.
Hi, I'm Zach, and I designed and built the electrical setup using the majority of parts I already owned, in combination with a few parts borrowed from Mike Hegeda's for the ACM machine, also helping with the code for the final design.
Hi, my name is Hassaan, and I was in charge of the code for our ACM machine.
Hello, I am Rahim, and I helped in making the poster for our presentation, ensuring that it conveyed the important information about our project and that it is engaging to our audience. I also contributed ideas to try and make our project better. I also helped in looking into finding parts for our project.
Hi, my name is Harandeep, and I help with the design process and the poster presentations. Initially, I brainstormed design ideas with my team. I also helped to solve our design problems, like how a cable would be coiled and how it would be held in place. For the presentations, I also collaborated with Rahim to design the poster and its contents.
For the main electrical parts, we used an Elegoo Uno R3 in conjunction with a 4x4 matrix numpad and a 16x2 LCD screen for input and display. The Uno R3 controls the L298N motor driver, which powers the NEMA 17 stepper motor. To power these devices, we use a 9-volt battery to supply the Uno R3, and for the L298N module, we power it with a 12-volt power supply, which feeds into the adjustable buck converter, allowing for a step-down voltage and current limiting to the module. Finally, using the e-stop together with the L298N to cut power to the motor when needed.
Our programming is shown in this flowchart. All steps of the flowchart have been turned into a simple user interface that is shown on the LCD screen. This allows the user to select the settings of the machine before coiling begins. The settings of the machine are determined by a few factors, including the diameter of the coil and the gauge of the wire. This system was created to make the wire coiler safe and easy to use. Also here is our button guide, which maps the buttons on the numpad to their corresponding functionality. We created this button guide to make it more user-friendly.
First, we show the restart and e-stop functionality of the device. Next, we show the testing done with different cable lengths and gauges at different diameter loops. In order, we have our tests as small diameter, small gauge, medium diameter, medium gauge, and large diameter, large gauge.
Y squared equals x squared plus no. Yeah, equals y squared plus x squared. We got two sides. Yeah, and then you go dy over dt. That'll be 2 dy over dt. Yeah.
Finally, as for limitations and assumptions in terms of speed, it is currently actually slower coiling it with the machine than with your hand mechanically. So in the future, we plan to find ways that will cut down time.
Currently, we have to put tape around the stepper motor for the rotating table to gain traction. So in the future, we should have another design to make sure the tolerance is perfect.
With our design, the person who is coiling the cable has to hold it. In the future, we will implement a tensioner system so that it's completely hands-free.
Finally, with smaller diameters, the cable tends to be tight, resulting in a harder time to remove them.